Now that we've covered all the nomenclature, it's probably a good time to do a bit of a review, and we're actually going to this time break this up, and instead of doing one big unit test, we're going to do two smaller tests. So the first test will just be on the nomenclature and some of the properties of these molecules. The second part that we go into with the reactions will be on the next test. So let's go over the page in your notes. It's 6-3 that goes through some of the review stuff that you need to know. And then you can start studying and practicing and getting ready for the test. So here's the review. We'll just go through kind of one point at a time, and I'll explain what you're expected to know for each one. And again, if you have any trouble or any questions with this, please come ask me questions, whether it's on Google Classroom or email or whatever. Don't let this fester. Make sure you come and ask somehow. All right. So starting at the top here, the first thing you need to be able to do is define organic compounds as compounds that, remember our rules. 1, they have to contain carbon. And 2, that there are some exceptions. So they say here the carbonates, the cyanides, the carbides, those are all the ionic examples of carbon-containing molecules. Remember, if it's ionic, it's not organic. And the oxides of carbon, like carbon monoxide and carbon dioxide, remember, those are not organic as well. So you'll need to have that for the first one. 1.2 is the piece that I've kind of gone through and done a little bit with on each family. You need to be able to identify and describe significant organic compounds in daily life, demonstrating a knowledge of their origins and their applications. So where do we get them? We haven't gone into that a ton. We'll go into that more in the second half, but in general, most of the places we get these organic molecules are from crude oil, a lot of them, although you can get them obviously from living things, and even the crude oil itself got it at some point from living things. So that's the generalized origins, but you do need to know their application, what they're used for, and just their kind of common uses. So for example, methane we talked about was a part of natural gas along with ethane. Methanol is a type of alcohol, although not the type that can be safely consumed by humans. Ethane, natural gas. Ethanol is the type of gas or the type of alcohol that you would be able to consume. It's also in gasoline and fuels like that. Ethanoic acid is vinegar. Propane's in your barbecue. Benzene is in a lot of these molecules that we talked about with the aromatic molecules. Octane is a common component of gasoline, or at least related molecules. And glucose you should know. Polyethylene, don't worry about yet. We'll talk about the polymers in the next section as well, because it has to do with more with reactions and things like that. So make sure that you at least know some of those basic molecules in each family and kind of what they're used for. That could show up on the test. All right. This is the big one, is this 1.3, and you need to be able to name and draw structural diagrams. Remember that includes all the H's. Condensed structural, where the H's are collapsed in to show what carbon they're attached to. And then line diagrams. So make sure you can draw all three. Make sure you can find formulas, including molecular formulas, like counting the C's and H's on a particular molecule. And that includes aliphatic molecules and aromatic molecules and hydrocarbon derivatives like the alcohols, carboxylic acids, and the esters. So the rules that go along with that is that the parent can contain up to 10 carbon atoms. So that's why I only went up to dec, because I will never ask you to name something that has more than 10 in the parent chain. It will only contain one type of functional group. So I'm not going to give you a carboxylic acid that also has an alcohol functional group or something like that, because that's too complex. Now that doesn't mean you won't see that on a test. I just won't ask you to name it. Quite often on a test, I will show you molecules that have multiple functional groups on them and ask you to identify which ones you can find or see, but I wouldn't ask you to name a molecule with multiple ones. The only exception to that is that the halogenated hydrocarbons and the alcohols, you can have multiples of those, like multiple of the same type. So diols, and trials and things like that. But I'm not going to mix and match to have a carboxylic acid and an alcohol, or an ene and also an alcohol. We won't mix them up like that on you for naming them. So hopefully that's kind of explained in that paragraph. So that's big, right? Every lesson we've spent a lot of time on practicing and learning the families, how to name them, how to draw them appropriately. So that 1.3, that's a huge chunk of the test. 1.4, identify types of compounds from the hydroxyl, carboxyl, and ester linkage and halogen functional groups. That's kind of what I mentioned, where I may show you a molecule and ask you to say, oh look, that's aromatic because I can see benzene. That one is a carboxylic acid because there's a C double bonded to an O with a OH on the other side. Things like that. 1.5 is structural isomerism. Now it just says define here, but that also includes being able to identify whether two molecules are isomers. And that you would do by just counting carbons and hydrogens to see if they had the same numbers. And if it was a written question, it would be something like, can you find the 4 isomers of a certain molecule? The last one here, 1.6, is that you need to be able to compare the boiling points and the solubility among the molecules. And I'm only going to ever do this in one of 2 ways. The first one is within the same homologous series, and make sure you know that term homologous series means like a family. So if I say the homologous series of ethanol, the rest of that series would be like methanol, propanol, butanol, etc. That's a homologous series. So within a family, you should remember that the bigger the molecule gets, the more carbon it has, the higher its boiling point is going to be. And typically, if we're talking about water, at least as a solvent, their solubility in those polar solvents is going to go down. So that's within a homologous series. That can be for any family. The bigger they are, the higher their boiling points are, and typically the lower their solubility is going to be. The other way we can ask you to compare them is not within a homologous series, but comparing different molecules, or at least different families. If we do that, though, I will leave the carbon content the same. So I may ask you to compare 2 carbon molecules. Maybe there's ethane, ethanol, chloroethane, and something like that, where the carbon content's the same. It's 2 in all of them, but I've changed the family, I've changed the functional groups on there. You need to look at the strength of the intermolecular bonds there, like London dispersion, dipole-dipole, and hydrogen bonds, to determine which one would have the higher boiling points and which ones would have lower boiling points. Okay, so that's the boiling points and solubilities, making sure you understand those points. Make sure that you know how to define a molecule as either saturated or unsaturated. Remember that we're not just looking for double bonds, we're looking for carbon-carbon double bonds. So a carboxylic acid that has a carbon double bonded to an oxygen is not unsaturated. But if you had 2 carbons double bonded together, that is unsaturated. And remember that aromatic molecules are not considered unsaturated or saturated. We just say they're aromatic. They're kind of their own separate thing because they behave differently than either of those groups would on their own. And solubility, I've kind of already talked about when I talked about the boiling points. So hopefully that all makes sense. If there's anything there that you're struggling with, make sure you let me know. Go back and watch some old videos if you need to. Reach out if you need some extra help or some extra practice. I'll see what I can find for you. Remember that you do have some old diploma exams you can go back into to look for some problems and things like that. And if there's anything else I can help you with, let me know. Otherwise, we'll probably start the test this week for this section. And then starting next week, we'll start to get into the reactions that all these different families do and in what circumstances they do one versus the other. So that's coming up. Otherwise, make sure you review this stuff, study up, get ready for that test, and see you on the next one.